Hello? Hello? Can we all hear me? Am I here? Am I around? Oh, uh-oh. Hang on, I can see something I do not wish to see. Give me one moment. Can you all hear me and see me? Yeah? Grand, thank you, Mariam. Okie dokie, let me just get rid of this. I can see like a recap of the stream, but it's like a couple of seconds like in the past. So it's like really weird for me to look at. Let me try and get rid of that. Because otherwise that is going to be really annoying. So bear with me while I get rid of that. Ah, there we go. Fixed it. Cool. Okie dokie then. Grand. How are we all doing today? How are we all? Halloween today. Fun. You all up to nice stuff tonight? What you all up to? We have a chat for 5 minutes. Why not? Nothing particularly pressing today. Just a bit of data stuff, which is quite fun. But nothing particularly taxing. We'll have a bit of a chat beforehand. How are you all doing? Anything good happened today? Tired it says about school. Oh, I go back to school today. I know some people. I think that makes sense. Whenever I went back to school and it was like Halloween, I always got this Halloween off, like just the extra day. Then back on Tuesday. That's what my brother's doing. He had today off and goes back tomorrow. Oh, you're all going back today. Oh, what a shame. Halloween, the one night you can kind of like have fun, and you're back at school. It's not very nice, is it? Yeah, that's what I always used to have when I was in school. My brother still had. My brother goes to the same school that I did, so he works in the same way. But yeah, that's a shame. Anyone else still on half term? I've got a couple of students that are like still on half terms. I had last week off and this week off. Anyone still have half term? Got a mock in November. Oh, good luck. Do you have it in everything, or is it just like your core subjects? Met with your friends yesterday. Oh, that must be nice. Did you get up to anything fun? What'd you get up to? Harry mocks too. Oh, fun. Mocks are never that good, are they? At least it gives you practice for like the real thing, you know? Because mocks they're quite handy to know roughly whereabouts you are, right? Mocks they're quite useful. At least they're nothing serious, unless maybe like your colleges will look at them or something, but hopefully not overly serious. So I'm not looking at the camera because the chat's like over here, so I'm looking in this direction. That's where the chat is. Sorry, I can't, not looking you dead in the eyes. But all got mocks. All here. Mocks are in the summer. Fun. Different exam schedule to us then. In the summer term. Oh, you in year 10? That makes sense. Normally year 10s have their mocks after the year 11s finish. Which is obviously, in June. They'll finish then. So then then have your mocks between like June and July. Or maybe just in year 11 and have like an international exam board who do all their timings a bit different than we do. Could also be that, I suppose. Not sure if it gets study leave. Study leave's fun because not everyone gets it. Because I teach a lot of students every year. I teach maybe maybe 20, 30, maybe 40 students a year. And I think around about half of them get study leave and half don't. And I think study leave can be like a blessing or a curse though. You have to be really organised for study leave to be effective. And if you're not really organised, then you end up just kind of fermenting at home, just like vegetating until your exam stress kicks in the night before. But if you're at school, your teachers kind of force you into it a bit more. So I think study leave is normally like a double-edged sword. Sometimes it works really well for people. Other times it's an absolute disaster because no one does anything. And everyone gets very stressed then because they've had all this extra time that other students haven't had throughout the country and they've completely wasted it. So if you do get study leave, you won't be one of those people. If you're attending a maths live stream on Halloween, and then chances are you're going to be quite maybe grade oriented. Because obviously probably a lot of better things you could do than me hanging out with me right now. But chosen this, which is quite nice, I suppose. Yeah, year 11 is going really fast. I can't believe it's already I'm saying nearly Christmas. It's not really nearly Christmas, is it? I'm wearing a Christmas jumper, but because I'm that kind of person. But it is going really fast. I can't believe, because I started with a lot of my year 11s this year in August, and it feels just so quick. Because I've got one of my year 11 students is sitting their first exams in March, because they do an international exam board, and that's 6 months away. Then April, when your last set of mocks is going to be. That's obviously, well, 5 months away. That's like 6 months away. It's crazy. Well, 7 months. It's craziness, isn't it? It's going by so quick. So maybe in like, I don't know, 8 months or so, your exams will be here. Spooky. That's the real Halloween scare, isn't it? Come here and you don't need to go outside for Halloween scares, or just to tell you dates. And that's all the scares you'll need. Oh yeah, I love Christmas. My Christmas tree, I've been arguing with my boyfriend about when to put the Christmas tree up. I think it should go up like next week. He does not. He disagrees. But I think it should go up like as soon as possible. I'm going to get like a little real one for my office and maybe put it like where my other plants are, like knock off the dissertation, but that's somewhere else. That's not as important as my Christmas tree. My like 3 years of hard work, irrelevant. My Christmas tree can go in that spot. So I'm going to get like a little real one to put it like up on my shelf. Get some like little lights and stuff. It'll be really cute. You're having them mocks right now. Oh, fun. Well, good luck with those. You're gonna fail. Well, don't think like that, you know. And if you do fail this week, at least you know it's a kick up the butt to revise more for your real ones, you know. So if you don't do well in these ones, then at least now you'll know that you need to put more effort in than what you have done. You know, at least mocks, that's the joy of mocks, right? They tell you that you need to do work, essentially, because not many, I think a lot of people don't do well in their mocks. That's why I see a boost. People want intuition, like at the end of the year, like going on like January, February, because everyone suddenly realizes, oh, I failed my mocks. My exams are in 5 months. That's not good. Olivia, please help me. And then that's when I get called in for emergency intervention. Maybe that's advanced now. Well, I think some schools are just a bit keen, aren't they? I think some schools, so I had one set of year 10 mocks that was like right at the end of the year, like end of year, like year 10, like I think it was like in July. So it depends on like how active the school is, how much space they have as well. If they've got space to do loads of different sets of mocks, then I mean, they're gonna, right? But yeah. And then let's answer some questions first, and then I want to do high paper on foundation. Yeah, talk to your teachers. They're the only ones that are able to move you. No one else can move you. So you got to prove yourself in the mocks. You got to show to them that you can do really well and you can pass a maths paper. Obviously, you can't pass foundation. You're going to struggle with higher maths. So yeah, you got to pull your socks up, do really well in your mocks, and then prove to them that you can. Cool. And then if you think you're already doing that, then get your parents involved, because they can often help as well. Help sway teachers when they don't listen to you. But anyway then, cool. So, yes, we are doing maths today. Just nattering away. It's been 13 minutes already. Well, it's been 5 minutes already. That's not that long. So week 4, we're going to do some scatter graphs and some pie charts today. Possibly a little bit of Venn diagrams if we have time. We'll see. I've got a couple of things to do. We'll see how we get on. Because these sort of stuff, I just wanted to do like on data, because foundation paper, the majority of the paper in like either Edexcel, AQA, OCR, they're all the same. The majority of the paper is data. That's all of it, pretty much. Like slight bit in algebra, it's like half data. Then I have like a quarter in algebra and a quarter in ratio. Maybe actually missed off shape, but you get what I mean. Most of it's data. So I thought I'd put a bit of emphasis on it. So yeah, anyway, any more questions, store them in the brain. We're going to come back to this later. Yes, we are. So don't worry, we will store this later. Let's do some maths. That sounds good. Grand. Okie dokie then. So, let's see. Let's do it. Moving on then. So first things first, going to be scatter graphs. Fun. What is a scatter graph? You guys tell me, what on earth is a scatter graph? Do we recall? What is a scatter graph? What is that when it's at home? What is a scatter graph? Any ideas? What are we all thinking? Way to plot coordinates? Yeah, you're right. It is indeed. A way to display data that has like a coordinate set. Perfect. It's a graph where the results are everywhere on the graph. Yeah, sometimes, yeah. So there's different correlations, and that would be what you've just described there would be a no correlation. But then there's different ones. There's positive, there's negative correlation, there's no correlation. Different types. We're going to look at others today. But yeah, perfect. So a scatter graph is just a way to display data. right? Just a way to display data. Normally when you've got two continuous sets of data. Any idea what that means? What does continuous data mean? Continuous data set versus like something that's non-continuous. Any ideas? Continuous data versus non-continuous data. Continuous versus non-continuous. Possibly with examples if you have any. What are we thinking? Pardon me. Trying to also see how badly the chat's delayed. I don't think it's too bad. Is it over time? Yeah, essentially, yeah. Perfect. Data that's continued. It could be over time, not necessarily. Essentially, it's just data that you can kind of have less in between values for, if that makes sense. So say with height, it could be 150 centimeters, 106 centimeters, and anything through that point. If that makes sense, you can be like 151, 150.5, like any interval of heights. Just depends on the accuracy of the measurement tool that you're using. With non-continuous data, that's like the color of a car, right? That's either one color or another. There's like a mixture of colors. That's still like a color, right? So you can't have a car that's like half blue and half red. That'd be then a new color. Does that make sense? So non-continuous data is a data that's like one thing or another. You can't have like 0.5 of a color, if that makes sense. Yes, non-continuous data and discrete data, yeah. Those are the same words, essentially. I use non-continuous and continuous. And it means the same thing, essentially. So yeah, perfect. Does that all make sense? So like height and weight, they will be continuous. Non-continuous would be like the color of a car, the color of my clothes. Normally things like color. It tends to be color. But cool. Anyway, let's get started. Stopping detouring. So here is a rather poorly drawn scatter graph. Oh, you can't even see it. Oh my gosh. I'm still on the wrong screen. There we are. Oh, I forgot to change slides. Anyway, you haven't missed anything. All it said was scatter graphs. That's all you've missed. So here is a scatter graph. So what we're going to do for now, because it's kind of tricky to like obviously draw one because you don't have the PowerPoint, you don't have the data set, you probably won't have any graph paper. So what we're going to do instead of really drawing one is we're going to look at things that are like wrong with graphs. So then from that you'll know how to draw a good graph because you'll know how to not draw a bad graph. Double negative. Hope that makes sense. Somewhere around that. So, let's read that out then. Mr. Jones, a shopkeeper, is analysing how his umbrella sales for each month relate to the monthly rainfall. He represents the data in a scatter diagram. Okay. Mr. Jones has made some mistakes. What are his mistakes? So I'll let you have a little think. What are the mistakes Mr. Jones has made? Give me all three. Give me one of them. Let's have a little think. Can we see it okay? It's a bit small. I can try my best to make it a bit bigger if we need be. Actually, let me try doing that while you're thinking. If you can see it, then fab. If we can't, I'll try and make it a bit bigger. Yeah, I can't really see it. That's fine. I'll try and make it bigger. It's hard to plan these things because it's like it looks a bit different when I'm like in the planning screen versus now. Let me see if you can still. Is that better? Hopefully. Can you see it better now? The points might be still a bit funny. That's okay. If you can't roughly read the points, don't worry about it. I don't think any of these... There's one point that's wrong. Well, kind of like a spotting game now. Which point is wrong. And there's one point that's not right. But everything else can be read just from looking at it and reading some like maybe the axes and such. So let you have a little look. Spotting what's wrong game. Give you a little second to think about that. One that still has a result of 85, 100. I think it's just below. It is hard to read, I'm aware. Maybe scatter graph wasn't the most ideal thing to have picked in the world for one of these sessions. But I think that point is one that's right, because I think it's just below. You can kind of see, I'll see if I can zoom in a little bit, just on that one point. So apologies if you're like glancing at something really hard, because it's going to disappear in a second, but I'll see if I can zoom in. So you can see it's kind of just short of that line, like the middle of it's just short of it. So I think it's meant to be this 99 point here. So that one is drawn correctly, but it is tricky to spot. So good guess, or good attempt. Let me move that to a place where you can see it. There we are. Okay. What else? The units are bad. The umbrella sword units are about 40, but there's no 40. Yeah, that is a point, yeah. That wasn't one of the mistakes that they listed in the question, but that would be not really a mistake. It's just kind of just a poor plot, essentially. He could have used something called an axis break, which looks a little bit like this. You might have seen a bit of this in like physics, called an axis breaker, which essentially, if you've got data that doesn't start at 0, you can use an axis breaker. Looks a bit like that, which essentially just shows it's not starting at 0. But you don't need those. You don't need axis breakers. But you're right, it would have been a bit nicer if it started at 50. Because all the other data starts on 50, so you're right. No point for it to start at 40. I'd accept that. So perfect. That's one thing. There's no plot at 30 or 29. Let's have a look. 30... Yeah, it looks quite good. Some of those are sold under 40. Yeah, it is. But they haven't plotted them. Oh, I see what's happened. But you possibly see what's happened once it clicks, possibly. Hang on. Yeah, something might click in a second. Yeah, this is a problem. You are spotting a problem. What the problem is that we're all spotting at this moment in time. What's he done to his axes? I think so anyway, if I'm looking at it briefly. I think there's everything wrong with this graph, to be honest. But I think his axes are the wrong way around. Let's have a look. So I have that. I think there's... Yeah, I think his axes are the wrong way around. Are we all seeing that? I'm seeing that. Because we are all right, because there is none under 40 down here, but there is ones under 40 here. So it's either not plotted the points, or this cluster here makes represent all these ones that are under 40 here. So I think these should be the reverse. So yeah, we were all spotting the same problem. It's just that we had different interpretations of the problem, of said problem. Which is kind of tricky. That's a tricky thing with these questions, because you're looking, you'll notice something's wrong, but you won't know quite where it is wrong until then. Yeah, it's funny once you notice it. Like, it took me a little while to see it as well. Once you notice it, though, it's like, oh, that does make sense. Why did I not spot that sooner? So that's that. And so that's one thing that's wrong. There's one missing point. It's somewhere. There's one more thing wrong. It's to do with the units. Give you a clue. It's to do with the units. Have a little look. Something wrong with the units. Yeah, millimeters and kilometers. They've switched the unit for whatever reason. They read the rainfall in millimeters, but they've written it in kilometers here. Which, I mean, if they had rainfall of several kilometers, that'd be some quite some rainfall, wouldn't it? Quite dangerous rainfall. That'd be way too much. That'd be some major flooding happening. So yeah. There we are. Does that all make sense? So those are the three. So these kind of questions, they're tricky, right? Because it's up to kind of interpretation as what the mistakes are. But that's that. So does that all make sense? So making sure our axes are plotted correctly, one thing. And maybe including an axis break or starting at points that make more sense, like this gap here. Even though they put it in the wrong way around, this gap here is still no good, right? And then And you go to the axis breaker if you fancy being fancy, and then making sure that your units match what you've measured them in. Make sure you put units all together. It's also something you need to remember when you're plotting a graph. Yeah, he did. Very silly. Mr. Jones. Just silly goose, isn't he? Right, let's just move on. So that's that one. We'll do one more like this, because they are quite tricky to read. So I'll do one more like this. We'll move on to something a little bit easier. So there's this one then here. So there's no data plotted incorrectly with this one, so it's a little bit nicer to see. So I'll make this a bit bigger again. Give me 1 second while I make it a bit bigger. Let me paste that. Let me plop that over there. There we are. Right. So Wayne has data about the number of goals 10 football players had scored and the number of games they had played. Wayne has plotted the points correctly this time. Write down 2 things that are wrong with his answer. And this one is very common. They have this all the time. I see it like in every exam board. Like every couple of years this will come up. These exact problems as well, like word for word the same problems. The exam boards are not very creative in some of their questions. They like reusing certain stuff. This is something they do like reusing. So that's why I'm trying to make sure we do one like this, because they love stuff like this. This is their favourite type of question. So can we see it all? Yes, we can. So all points put correctly. Well, there's no table to check anyway. There is 10 of them. So that's not the problem either. It's other stuff. Have a think. So Mikhail said the line of best fit is not going through some of the points. Yeah, that is indeed. Does it have to go through all the points, the line of best fit? Does it have to go through all the points, every single one? And it goes 25, 30, 45, or 40, 45. It's not the same spaces. Yes. How do we say that more mathematically, Erin? Because that is exactly right. But how do we say that more kind of mathematically, essentially? Yeah, you're right, Mikhail. So it does have to go through majority of the points. The way I kind of think about it has to be the same number of points above the line of best fit and below it, roughly, right? It doesn't have to be like the most accurate thing in the world, but it should be roughly, it could be like 1 extra above than below, for example. But it should be aiming for same points above and below, and that should get you like through the central of most of them. Have a look. Let me see what I've missed since I was talking. Yeah, should not start from the origin. Yeah, so the line of best fit's looking like it's trying to force itself through the origin, but in this case, it's probably not going to go through the origin. It's probably going to cut slightly before it. Yes, it's something to do with the scale. Equal intervals. Yeah, that'd do. And what I would say is not increasing in like a consistent. It's consistency that they're lacking with this. So I'd make sure I put the word consistent in there. So the scale on the y-axis is not consistent. That'd be what I'd put. Does that make sense? So the y-axis scale is not consistent. That'd do. So yeah, 2 problems. Line of best fit does not match the points. And the y-axis scale is not consistent. And there we are. Perfect. Do we have any questions on any of that? This comes up all the time. They love this question. It's their favourite question. On the higher paper, it's normally about question maybe 2, 3, very early stages. Foundation, maybe question like 20-ish. Depending on the exam board. But what's line of best fit? Good question. So a line of best fit is this line that they've attempted to draw here. So a line of best fit essentially kind of summarizes your data. So you can kind of see the trend of your data just by looking at the line, right? So you can see that the trend in the data, it does increase, but it should be steeper of an increase than what it is. So it should be an increase of something. I'd say the line of best fit was maybe something 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. Something like that. That's where I would put the line of best fit. So then you got 1, 2, 3, 4. Yeah, 1, 2, 3, 4 points there, and 1, 2, 3 points there. And it goes roughly through those 2. So that'd be where I'd put the line of best fit. It should be a lot steeper than what it is, which would suggest that there was like more goals scored for games played. I hope that makes sense. That's the line of best fit. It basically just summarizes the data, essentially. You can see like the gradient of the line kind of tells you things about the relationship. Does the line of best fit have to go through the points? Because there's 5 points inside. No, because it goes, as long as it's as long as it fits the points. Right? As long as you've got, as long as it looks like it's going through the middle of the points, essentially. So your line of best fit could, in theory, go through none of the points. Could touch none of them. Right? In theory, it could. If these points up here, if one was up there, if this one was like slightly higher, this one was like slightly lower, like there, this would still work as a line of best fit if it went through none of the points, right? It just has to go through like kind of an even, like kind of even space it through the middle, kind of like parting the Red Sea, right? Has to go through like, but there's more, the same amount above and below, roughly. Like maybe one, you can be one out or so, but does that make sense? It should be roughly same amount above and below. So it could go through none of them, or it could go through all of them. Doesn't matter. As long as it's, as long as it works for the data set that you have, essentially. So how do you find the line of best fit is? It's kind of, I kind of eyeball it and then double check that it works. So you want it to go through, you want to try and make it go through some of the points. Sometimes it's not feasible, sometimes it's not possible. With this, I can see that these points are kind of roughly in the middle anyway. So I'm going to try and make it go through these ones. And then from here, it could technically be there as well. It really is a bit of a range. So they don't mark it very strictly. They normally have it marked like the amount of it can be kind of in a spread of places. So it doesn't have to be like exactly in one place, and that's the only place they will accept. Normally they'll accept roughly in a couple of places. Because normally when they get you to draw a line of best fit, they get you to like extrapolate data from it, like read from it. Like say if I wanted to know like how many, if they played 80 games, what the total number of scores goals would have been. So they normally get you to read off it like that, and then there'd be a range of answers depending on what your line of best fit was. And yeah, this question would have been 2 marks, 1 for each reason. You don't have to do anything with the reasons, it's just writing down a reason. Thing. Is the point of positive? It is a positive correlation. Well done. So a positive correlation is where the line of best fit looks like that. You can also read correlation from your line of best fit. So correlation is kind of where the data is headed, essentially. So if it goes like upwards motion, like going from bottom left to top right, positive correlation. Top left to bottom right, like this, that would be a negative correlation. It's going, it's going back the way. So negative would be your points going kind of roughly around like kind of that, where they're going downwards, like a downward projection. And then no correlation would be like that, where all the points are everywhere. Like what you've got on these axes, there's no correlation between them, there's no relationship between them. The points are just everywhere, which would kind of be, what would that be? Kind of, I don't know, length of your torso versus like length of your foot. Maybe it's slightly correlated, but not particularly correlated. Does that make sense? So 2 things that are quite different. Or like score on a math test versus height. Those 2 things will not be related. So that would look like this no correlation graph that I've got on here, where all the points are scattered everywhere. Does that all make sense? Do you have any other questions about this graph? Because that's asking a lot of good questions. Don't move on till I've answered them all. Do you have any other questions on this lovely graph we have here? Well, not particularly lovely. Poorly drawn, but alas. I'm going to take that as a no. If someone's writing a paragraph, big bulky paragraph, then I'll come back to it. But we'll move on for now, because I'm a bit cautious on the time, such as scooch along. So there's one more thing I kind of want to touch on, which is this graph here. I thought it'd be quite interesting. So this is the graph that was on the news, like right near the start of COVID. I think it was around maybe July of 2020. So reasonably, obviously, kind of everything kind of kicked off in February. So kind of midway through, maybe it was later. I can't really remember. But anyway. So this is a graph that was used at some point in the BBC during COVID, right? And something is wrong with this. So I'll make it a bit bigger so you can kind of see it. They were being a bit sneaky with the BBC. They were being very misleading with their graph. I remember Ofcom getting loads of complaints about this, and I was like, I shall use this in a lesson. So this is, don't know what his name is, but BBC presenter with his graphs on COVID. So let you have a little look at that. Can we spot what is particularly misleading about these graphs that we have here? I think so. Do write notes. I mean, you can do if you really want to. Up to you. I mean, everything I'm saying is on the math syllabus. This one, maybe not. It's just, I don't know, using critical thinking when looking at graphs on the news. Kind of show a bit of that, because even graphs on the news that you see around, like from reputable sources, still possibly have some bias, as this one I believe does. But so maybe showing some critical thinking. So can we see roughly? I know it's quite hard to see with the numbers, which they've done on purpose. These numbers are hard to read on purpose. They've done this intentionally, so it is something wrong with the numbers. Let me have a little think. People are going to be asked you to see in which paper. So really anything on any paper in the Maths GCSE, apart from like maybe like exact trig is one thing that will be only in paper 1 or paper 5 for OCR. But it's really anything from any paper. There's not really stuff that's only in paper 1, only paper 2, and only paper 3. Anything can be anything, apart from stuff that like if you need a calculator for like cosine rule, that would be paper 2 or paper 3, or 4 or 6 if you're OCR. So there you are. Let's have a look. The numbers on the y-axis aren't the same. Yes, you're absolutely right. So if we were looking at this graph, so say if we were, I don't know, start watching 6 o'clock news, eating my tea, my like beans on toast or something, and I was just having to, casually watching the news and having to see these images in front of me, I think, England's doing pretty good. Well done, England. Scotland in a bit of a dire straits. Northern Ireland getting worse. Wales also getting up there. But what they've been quite sneaky about is the heights that each of these peaks go up to are very, very different, right? Have we noticed? This one, England peaks at 30,000, whereas Northern Ireland, the highest one, is 700, a measly 700, right? But these peaks look equal. So if we were just scanning, like casually looking upon the news at that night, and then we would probably think that England were in a similar situation to Northern Ireland, or to Scotland, or to Wales, when really England were really, really, really not doing good when it came to COVID numbers. So yeah, how sneaky was that? BBC been very sneaky with their graph work. So yeah, possibly Downing Street has something to say about it, but I don't know. So yeah. How do you feel about that? So yeah, be wary of graphs you see on the news, on Twitter, on wherever it may be, because they may still be misleading. Even if I'm a reputable source like the news, they could still be kind of trying to put forth a message that possibly is not the best message to be put forth. But there we are. Grand. Cool. Moving on then. So something else I wish to do in this space that we have is pie charts. That's what was set aside for today. Also pie charts. So what is a pie chart? What is one of those things? What is a pie chart? What is a pie chart? Yeah, they couldn't get me. I remember seeing it on the news. I was like, I don't think I trust that. These numbers look a bit dodgy to me. I remember pausing it. I was like, I swear England's doing worse than Scotland. I remember reading it earlier the day, and I was like, I swear England's doing not as good as Scotland and Wales. I remember pausing it and like properly going to my TV and looking at it. I was like, BBC being sneaky. Yeah, it is perfect. All these are right. So yeah, it's a circle split into sections like slices of the pie, which breaks data down into like percentages. You're absolutely right. Fantastic. So let us go through then and have a look at a pie chart. So this pie chart shows information about the money Fiona spent last month. So out of all these things, I'll zoom in a second. What did Fiona spend the most money on? So out of all of these things here, let me zoom in a little bit so you can see it properly. What did Fiona spend all her money on this month or last month? What was Fiona spending all her cash on? Rent and bills. She was indeed, much like the real world, Fiona was spending all her money on rent and bills. Perfect, absolutely right. Rent and bills. Cool. And then what fraction of Fiona spending, that should be, was on transport? I didn't make these questions. Apologies for the for the misspelling. What fraction of Fiona spending was on transport? It was indeed a quarter. Perfect. Absolutely right. It's 90 degrees at 360 degrees, which is indeed a quarter. 90 over 360 will simplify to a quarter. Perfect. And then Fiona spent £320 on transport. How much did Fiona spend in total? A little bit trickier. Let me go have a little overthink. Yeah, I'm seeing some good numbers. Perfect. How did we get there? How did we get to £1,280? For the people that don't know, how did we get there? How did we do it? Perfect, yeah. 320 times 4. Because if 1/4 is 320, we want to work out how much you spent in total. In total, that would be 4 quarters, right? That would be like the full one. So then to get from that to that, we times by 4. So we're going to do the same thing there. That times by 4, 1,280. Grand. Okie dokie. Any questions about that? We all making sense? That one's quite a nice one, I think. Quite a good pie chart was that. About a grade. It was a bit simple for the high paper. That would be about a grade 3 on the foundation paper. But not too easy. We'll do one that was on the high paper next. That'll be next up. And then we'll go through and draw one. But how do we feel about this? Feeling good? Feeling ready to approach a higher paper one? Yeah? Hopefully. Then there's a little bit of a lag. I'm not really sure. Yeah, grand. Okie dokie. Cool. Let us continue on then. So, yes, here it is. The listed form was a higher paper. So, an AQA 2017 paper 1. So, the 4 candidates in an election were A, B, C, and D. The pie chart shows the proportion of votes for each candidate. I'm going to make it bigger in a second. Work out the probability that a person who voted, chosen at random, voted for C. So, it's mixing in probability, which we haven't done together yet, but hopefully we should have a rough idea on just from school. We've seen probability for quite a while now, since, maybe not the harder stuff, but this sort of stuff, since probably about year 7, year 6-ish. Anyway, let you have a little think. So the bit of algebra in your pie chart. So the 4 candidates in an election were A, B, C, and D. The pie chart shows the proportion of votes for each candidate. Work out the probability that a person who voted, chosen at random, voted for C. You have a little think. I'm going to work it out too. I haven't done this one yet. Let me have a little think. There's a pen. We'll have a go. Keep it clear. See, with forming equations as well. You might have to form an equation in this case. Number next to 10 in C. So it's this little one is just a degree sign. That's a degree sign. So this whole angle is 2x plus 10. That little 10 is next to degrees. Little degree sign. That's all. Not an extra like 0 or anything. Just a degree sign. So I'll give you a couple more minutes and then we'll go through it if you're stuck. Let me know if you have any questions while you're all doing it. It is tricky. It is tricky. It's not easy. This was a particularly tricky paper as well. I remember doing this last year with a student, and they didn't like it either, and they were aiming for a grade like 7-ish, I believe. And so it's not an easy paper by any means. Definitely not. Give me 1 second. So someone's come up with an answer. Let's have a little think. Okay then. So let us go through it. With probability, you have to simplify if you don't want to. Probability, you can leave it as the unsimplified fraction. So the one case where you have to simplify, which is quite nice. Okay, let's have a think then. So we have got all this data. So essentially, we want to find the probability that the person who voted, chosen at random, voted for C. So that probability, so probability is always the amount, the proportion, I can't speak, the amount of people that we want for a specific thing. So in this case, the amount of people that voted for C out of the total number of people, right? So probability so is on top, the amount of people that you want for a specific thing, like vote for C, vote for A, I don't know, scored number 2, whatever it may be in the certain context. So that is going to be the amount of people who voted for C. So amounts for C. Well, no, it was a paper 1, so it was not actually. It was a non-calculator question. So it's the equivalent of a paper 5 in OCR if you do OCR. So amount of people who voted for C divided by the total. You can just about see that. Total. So we don't have any numbers here, right? So we can't be finding the exact number of people that voted for C because we don't have any numbers to put to any of these proportions, right? So what we're going to do instead is work with just the proportion that the angles are telling us. So if we work out the angle of C, we can put that, so angle of C, over the total, which is 360. And that'll give us the same proportion that we would have gotten if we had the exact number of people. Does that make sense? So we need to work out this angle of C here. So that all makes sense to everyone. So we just want to work out this angle here. We're going to put that over 360. That makes sense? Hopefully. Cool. Then what we're going to do from here is, I know that because this is a circle, right, this is the pie. So all these ones in here are all they're all differently like shaped, and they've done that kind of on purpose to make it look a bit disjointed. But in the middle, we've got a circle, right? We've got that. That could be the 2x, that can be the 90, and that can be the x. So we've got a full circle. So if I add all these angles up, that's going to give me 360 degrees, right? So if I add all them up, I've got 360 equaling 90 plus x plus 2x plus 10 plus 2x. So I'm forming an equation, bringing all these angles together and making them equal to 360 degrees. Then it's time to simplify this algebra. So I'm going to bring all my numbers together, which is 90 and 10 just for now. So then I've got 360 equals 90 plus 10, which is 100. And then I've got x and 2x and 2x. So altogether, I have got 5x. Okay, are we all following so far? Is it all making sense? I hope so. Let me know if it's not, I'll go back. Let me carry on for now. So we've got 360 equals 100 plus 5x. So I want x on its own. So what needs to move is that and that. They need to shift. Right, I want x on its own. Everything else got to shift out of the way. So I'm going to move this 100 first, because dividing by 5 now, you have to just do it twice. Bit of a pain, right? Move the number first, divide by 5 from like one number. So I'm going to do then 100, well 360 minus 100, which is 260. And then that is an equal to 5x. And then I'm going to divide 260 by 5 to get rid of that 5. And I'm going to get whatever number that is. I can't do that in my head. I would do bus stop, obviously in a non-calculated paper. But I'm assuming you all know how to do bus stop. So I'm going to use cheats, use my calculator. So x is then 52. Cool. How are you all feeling about that? X is 52. How's that all made sense? Have we been following thus far? That's okay. Your answer was very nearly right. So I think it is right now. And then what we're going to do is, we now know that the angle x is 52, but we want this angle here, right? We want 2x plus 10. So what are we then going to do to be able to work out this angle? If we know that x is 52, and we know that this angle here is 2x plus 10, what are we going to do to work out this yellow angle there? What are we going to do from here? So what size is that angle there? That angle C. Perfect, we are indeed. And we're going to substitute. Fantastic. So I'm going to put this in there. I am indeed. So it's going to be 2 times 52 plus 10. So that is going to be then 104. 50 times 2 is 100. 2 times 2, 4. So then I'm going to double that and then add 10 to it. So that is 114. Okie dokie then. So then it's 114 out of 360. And that is your final answer. Nothing more needs to be done with that. That is it. That's all of it. How was that? It's quite tricky, I know. That was a tricky higher paper question. I mean, it's high paper, all meant to be tricky, right? Everything's meant to be hard on the high paper. It's not meant to be easy. But how have we felt about that question? Makes so much sense? Good, 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 good. So essentially, if you've ever got a load of algebra and no numbers, you're going to have to form an equation somewhere with some angle fact. That tends to be the way that it goes. So it's either you got a circle, or you got a line, or more often than not, you've got a triangle. You have to make some form of algebraic equation just using the algebra that you've got. And normally the angle fact is angles in a triangle out to 180. They do it all the time with that one. But this one's also quite common. Angles in a circle out to 360. There's actually not much a circle theorem, not much a pie chart question. It's more of an algebra question, isn't it? But there we are. Cool. All making sense? How are we feeling about this now? Feeling good? 57 over 180. You can half it. You can. So you can simplify that fraction, but with probability, you don't have to simplify it because technically this one tells us more about the proportion, if that makes sense. That one tells us more, like it tells us there's 114 people out of 360. It kind of tells us a bit more about it. So probability is the one time you don't have to simplify your fraction. Every other time, yes, you do. But probability is that one time that you don't. Because in theory, you can gain more from not simplifying it. But if you did simplify it, you still get the marks. You'd be fine. You still get all the marks. Grand then. Cool then. So we've got a couple of minutes left. I think that in that couple of minutes, we can have a little look at a Venn diagram just for fun. I like Venn diagrams. I think they're quite fun. So I'm going to give you... I'm going to give you this one just for fun. So if you fancy doing a bit of an extension question... This one is the extension. This one's tricky. I'll make it bigger so you can read it. So we're going to end the stream in about 7-ish minutes. But it should be more than enough time to have a little go at this question. Let you have a go at it. Bit of an extension. It's not a Venn diagram. It's the Venn diagram. So yeah, because pie charts kind of done all that there is, essentially. Especially on the higher paper. I don't think they've ever gotten you to draw a pie chart on the higher paper. I think they've ever done that. Foundation, yes. But I'm assuming from what the trend I'm seeing, like last week and the week before, most people in this chat will be higher paper or aiming for higher paper. So I don't think there's much point in us drawing a pie chart. I think the majority of us will never have to do one. But this sort of stuff, they would definitely have to do one. So let me read it out. So Sammy asked 50 people which drinks they liked from tea, coffee and milk. All 50 people liked at least one of the drinks. 19 people liked all 3 drinks. 16 people liked tea and coffee but not milk. 21 of the people liked coffee and milk. 24 liked milk and tea. 40 liked coffee. 1 person only likes milk. Sammy selects at random one of the 50 people. Work out the probability that this person likes tea. I know, a lot of stuff all at once flinging at you, but try and break it down into your Venn diagram. Let you have a little go at that. And if you, obviously this is quite a lot for Halloween night. So if you don't feel like doing this, don't worry. You don't have to. It's kind of an extension question. It's beyond what we're going to do today anyway. We've gotten through what we wanted to. Gone through scatter graphs. Gotten through pie charts. If you want a bit of an extension on a Venn diagram, then feel free. This one it's a bit of an extension. It's tricky. If you don't fancy it, then someone has put, well, me, it looks like, but someone else has put in the chat it is a, trying to think of the name, a survey, that's what it's called. I thought we were going to say it in the message, so that's why I read it, but a survey. So if you want to fill out the survey, just to tell me what you liked, what I could improve on, all that sort of stuff, you can win a voucher. How fun. £20 Amazon voucher. Go buy some a Halloween costume for next year, I guess, with that 20 quid. So yeah, if you do fancy filling out a survey, it'll be really helpful for all the folks at my tutor, because obviously this is kind of a limited run thing. So if you do like them, then feel free to get in touch with them, because then chances are they'll do more of them, which would be fun, wouldn't it? So if you did like them, if you find them helpful, let them know. They might do more, which would be fun. But cool. Let you have a little go at this. I might start setting mine up so that I can fill it in at some point once we've all had a go at it. I'm just gonna put my circles down. That looks about right. Tea, coffee and milk looks good. Tea, coffee and milk. Obviously you'd have to label the circle exactly as I done. Oh no, you can't even see one. Uh-oh. Maybe shuffle it over a little bit. I hope they can still see that. Okay, dokie then. So that is that. Cool. I'm going to go at this on my own, actually, before I embarrass myself by getting it wrong in front of all of you. So I'm going to have a go at it. When I finish it, then we'll go through it. I won't take too long. I should hope anyway. To let you have a little go at it. Or just calculate if you like. It could be on the non-calculator paper, but it's just subtraction. Just kind of annoying without a calculator. And if you also have any questions about these sessions that you particularly like to ask, then also let me know. Then when we're approaching the end, then we can answer those as well. If you have any particular burning questions about these. This is a tricky one, actually. Yeah, well, I think that one £20 voucher is between 3 lots of streams. Unless Matthews wants to correct me, feel free. But I think it's because I think it might be the same one for me. And then Fliss does coding on Tuesdays, and then Ketia does study skills on Thursdays. So, I mean, if you want to try and work out those probabilities, I'm not sure. I think it might be. I don't think it's as low as the lottery, but I mean, it's not a lot. Not everyone attends these live streams, you know. So. I don't think I think it's kind of still a bit of a long shot, as it is with anything on the internet, isn't it? As it is with learning anything. But let's have a think. This one's tough. Let me have a go. I don't know. You're getting distracted reading the twat. The twat leaving in the chat. Let me carry on. Okay then. Well, what are we going to start with? What are we all going to start with? Any ideas? Let me, 1 second. I need to just do something. I think it's going to open up somewhere that I don't want it to. To Daisy. Move that over there. Okay then. So, any idea? I'll let you all have a think. This one's tough. I'm trying to give you this one right at the end, because it is really, really tricky. So I'll let you all have a good think. Yeah, 19 likes all three. That's definitely what we're going to start. So let's put that in the middle. And then what I would do from here is do a bit of like a running total. So what can we, how many people have we still got left to put in our diagram? $31. Absolutely right. Bear with me, let me just deal with that. 1 second. Hopefully you didn't see. Okay then, so you're absolutely right, there is 31 left. So we put this one, so let's get rid of that. We know we've done that one now. So what else are we going to do? What else is there? So 16 people like tea and coffee, but do not like milk. So where are these people going to go? Yeah. So in out of all these options, whereabouts are they going to go? Let me label them actually. That might be a really good idea. Well, I do that. So I've got 1, 2, 3 for the main circles, and then 4, 5, 6 for the mini ones, and then 7 we've already done. So which one of these options is gonna, yeah, between tea and coffee, which is number 4. Yes, indeed. Let's put 16 in there. Perfect. Okay, and then what next? What else is there? So can we do this one right now? 21 people like coffee and milk. Can we do that one? I'm saying no, because it's people like tea, coffee and milk. So that could be in, that could be actually, because that could be here as well. So where else could it be, actually? Now that I'm thinking about it, actually we can do that one. That's that right now. So what are we doing from here? Any ideas? I think we've got it. Yeah. So 21 people like coffee and milk. We've already got 19 here. So then how many are going to go in this slot here? Any ideas? So we've got 20 people like coffee and milk. 19 are already done because they like coffee and milk. So how many are left to go in here? Any ideas? Two. Does that all make sense? Because then 19 plus 2, that makes a total of 21. Okay, almost. Almost. I made silly mistakes like that as well. Is indeed 2. Grand. And then same streak from here. 24 people like tea and milk. So 24 people like tea and milk. Some of them are going to go in here, but then there's also going to be some of them in here. So how many people are going to be left to go in this tea milk collab zone? Number 6. Any ideas? This one's really tough. I should have been more. I should have looked at the question beforehand. This is way too tough for right at the end on Halloween night. But we'll stick through. We're nearly there actually, aren't we? So we're nearly there. Nearly done it. And then next one, 40 people like coffee. So how many people are going to go in here? In this number 2. If 40 people like coffee, how many are going to go in there? Yeah, 40 like coffee. How many are going to go in this number 2 here? So in all this bubble, in this 2, 4, 19 and 5, there's going to be 40. So how many are left to fit in this 40 column? 3. There is indeed. Perfect. Okie dokie. So that's that done. And then only one person likes milk. So what's going to happen there? That's going to go in here. And then let me double check, because that looks all right to me. I'm just going to go in this one. Then we'll end it there. It's really weird, isn't it? Because this looks like it's going to add to more than 50. Are you getting that too? Hang on. Maybe this question's a bit dodgy. Ah, well. Oh, no, it does. It does add to it. This is fine. Let's go milk so far. 1 in there for the milk. There we have it. And then, let me just double check. This is all 1, 19, 5, 2, 3, 16. Yep. So then, there's some people left that should be able to go in here. If I've done it right. I should. It's my thinking from the other day. I did it before, like ages and ages ago. But I've forgotten how tricky it was. And then, there should be 4 people left in here. Oh, what a tricky question. These are really tough, aren't they? There's 3 ones. 3 circled ones. They're really tough. They're not easy, are they? They're not easy at all. They're really, really tricky. So, well, I can probably see that this person likes tea. Picks one of them at random. So how many people in this Venn diagram like tea? How many people like tea? All of them. Yeah, perfect. You got it. 44 out of 50. That was tough, wasn't it? So that kind of question, I believe, has come up once. It was the last question on the paper, on the higher paper. So this is tough. Tough stuff. Tough stuff. How would we feel about that? Really tricky. But how do we feel? Well, we've come out of the other end of it, right? And really tough. Really, really, really tricky. But how are we feeling? Feeling good? Hopefully. Right, we're going to end it there then, because I've already run over by 7 minutes. Michael's going to get upset with me, because I'm running over massively. But do we have any last minute questions before we leave? Anything before we go? Before I have to run off? Not there eventually. I mean, I guess that also shows that even with someone, I've got a first class degree in engineering. Sometimes I still even find that past paper questions are quite tricky. Like that one was quite tough. And I'm a engineering graduate, you know? So even I find questions tough sometimes. UTCs are not easy by any means. They're really tough. Okay, any last minute questions before we go? Hopefully not. Well, actually, hopefully not. I'm just worrying because are you guys deleting your own messages or is someone deleting them? I can't tell. Shouldn't be anyone deleting them. Can't imagine there would be. But anyway, how many are there? That's a good question. So this is week, let me have a look. This is week, where are we? Week 4. And there's, I believe, 10 weeks in total. So we're going up till about, I think, the 10th of December. End of December? Oh, it's your first time? Oh, well, hope you enjoyed it. Normally it's not as as scattered as this. Scattered question. Hope you enjoyed my joke. But it's, so there's other ones have been recorded. You're welcome to watch them. With the first week we did factorizing linear equations. Second week was quadratics. Third week was trigonometry. And then we're going to do week 4, scatter graphs and pie charts. Week 5 is going to be, we're going to do averages and box plots and cumulative frequency. And then I'm just going to have a look actually and see, figure out what all the weeks are. I've got them all in a list somewhere. Let me grab them. That'll be handy for you to know. And then, it's right here. And then week 6, we're in probability. Week 7, ratio. Week 8, straight line graphs and inequalities on graphs. Week 9, angles in parallel lines and circle theorems. Week 10, it's going to be simultaneous equations, both grade 5 and grade 9. Ah, spooky. Yes, so it's Mondays, every Monday at 5 o'clock. So I'm not doing SERDs. I know everyone wants SERDs. I'm really sorry, I can't do SERDs. Because basically, my tutor wanted me to pick lessons that suited both foundation and higher students, so no one was left out. And SERDs take like a full lesson pretty much to do. So if we did do SERDs, then foundation students wouldn't be able to participate because it's not on the foundation paper. So I try and do stuff where it's content that is still on the foundation paper but reaches like into the harder realms of like the higher paper. Like Simultaneous Equations is a really good example, right? Simultaneous Equations, they're grade 5, so it's top of foundation paper, but they do go up to grade 9, so higher students still aren't bored, if that makes sense. So I'm trying to do one topics where there's both, right? I know I can't. I wish I could. I love SERDs. SERDs are one of my favourites, right? I love SERDs, but unfortunately I can't. My tutor approved all the lessons in advance, so I'm stuck doing what I'm doing, but one day if we do more, obviously feel free to, there's a link in the description for like the live stream's gone, and if you want to make suggestions on future live streams, then put like a thing in the what's it called? I keep forgetting what it's called. In the survey, being like, can we please pick our own topics? So I'd be happy to do it. It's had to be approved, essentially. So if you do want it to be more like ad hoc and do like what you want to do on the day, then put that down. And then if we do any more of these live streams, like after December, let's say if we do any more in like the new year or something, and that would take that on board. So if you do want to make suggestions, then put that in the survey that you'd like to make suggestions. And then if enough people do want to make suggestions, then possibly you can make suggestions next time. SERDs are ones that look like this. Like that's a SERD, like a SERD symbol, like a square root symbol, but for square roots that can't square root, like root 2. That's a SERD. And that's what they're talking about. So they're about a grade 7-ish, as SERDs, ranging up to like a grade 7 to like a grade 9. What SERDs are. So yeah, if you do want to make suggestions, then put that in the like feedback. That'd be helpful for my tutor to know, I think. I can't do them, unfortunately. I'm not my tutor myself, but there they are. Cool. Any other questions before we wrap up? Anything else we'd like to ask before we call it there? I've already kept you over 15 minutes. I do apologise. Also wanted to get on with the rest of your Halloween night. But is there anything else we'd like to ask before I wrap up? Are we all happy? I'm assuming we're happy. Assuming so. Cool. So I'm going to end it there then. So thank you all for joining me today. Well, if you win, they'll email you, I'm assuming. That's what they've done in the past. If you win, they'll email you. So if you want to boost your odds, maybe do one every week. I don't know. Maybe do one. So a few other people are doing live streams. So Fliss has got one tomorrow at 5. She's just coding every week. And then Enketia is doing Thursdays at 5. He does study skills and how to best optimize your revision time. So if you go to those, and then I'll like boost your odds, putting your name in the hat more times for the 20 quid gift voucher. Obviously, I think you have to put like honest feedback. You know, it can't just be like random letters to boost your numbers. I think they're going to check everyone, make sure it's actual genuine feedback that you've actually been there and stuff. But it's a science one. Not quite. I do teach science, so I could do one, but again, these are maths. So if you do want a science one in the future, then again, put that in the feedback. They love to hear it, because they're just kind of trialing it for now with like popular ones. Like GCSE maths is popular, and then coding is very popular, and revision skills everyone needs, no matter what age you are, no matter what you're doing, or what exam board. So they're trying to do ones that like across the board, very easy, and like English is quite hard to do over a live stream because you have to like actually like talk about big long paragraphs and stuff. So that's why they chose maths to be one of the first topics. But science I think would also go really well, and less kind of format. So tell them if you want science. Tell them you want science. I'd be more than happy to deliver it. Oh, pardon me. And then can we watch the lives? Yes, you can. They're all uploaded as VODs, so video on demand, like tomorrow. So we'll probably be up about like midday tomorrow, I'd imagine. All the old ones are already up, so feel free to go back, watch those. Yeah, they're all recorded, and they can watch them all back, chat and all, which is quite nice. Cool then, grand. So I'll let you all go then. Have a lovely Halloween night. Have a fantastic evening. And I shall hopefully see you all next week, if you want to join again. Next week it's going to be averages and box plots. Possibly cumulative frequency, if we get onto it. But yeah, perfect. So I'll see you all next week. Bye!